In problem 13, we're asked if this following set is well defined, the set of U.S. presidents under the age of 20 while in office. So the question is that a knowable fixed amount, or is it a matter of opinion and everybody could have a different answer? And it's a knowable fixed amount. In fact, there aren't any, so it's the empty set. But we can put well defined. Problem 17 asks us about the set 1, 2, 3, 4, ... Wants to know whether it's finite or infinite. Well, it's infinite. Problem 21, the set of odd numbers greater than 15. What do they look like? Well, 17, 19, 21, ... That's infinite. We can't come up with a number that is the cardinal number, so it's infinite. ...'s a clue. 23 wants us to express the set in roster form, the set of all states in the United States whose first letter is H. Well, there's Hawaii. And I don't think heaven counts, so I guess that's it. That's the set in roster form. There's just one element in it, one state, Hawaii. 27, express in roster form all numbers that are natural numbers and even. So I'm going to start low. These are natural numbers that happen to be even numbers. I think that's enough to give the idea. And that, of course, is an infinite set. Problem 29, let me scroll up a little bit. Set of all football players over the age of 70 who are still playing in the National Football League. So I guess we have to ask ourselves the question, is New England's quarterback Brady 71 yet? And he's older, but I don't think he's 71. So I think that listing this in roster form, I suppose, would be the empty set. With nothing in it, not a zero, with absolutely nothing in it. Another way of writing the empty set, according to mathematicians, is this kind of O or circle type shape with a slash through it. Problem 41, we're supposed to write the set B in set builder notation. So the set B equals the set of all x's such that, and then it looks like those are all natural numbers, so I'll put x is a member of the natural numbers. And then there's all kinds of ways to write this, but we want to limit it to the numbers from 7 to 14. So we could put 7 is less than or equal to this supposed number in our set, which is in turn less than or equal to 14. That ought to do the job. Problem 45, E is the set of odd natural numbers. So E is the set of all x's such that x is a member of the natural numbers and x is odd. There's, of course, other ways to do this, but that's a way. Seems kind of basic, so let's do that. C is the set of the months that contain less than 30 days. So I don't really like this problem, but here's why. When you're using set builder notation for a set that ends up having one thing in it, it's just kind of useless stuff. You ought to just write the set. I mean, in problem 47, it seems to me February is the only month. So we ought to just put February in set brackets and be done. But I guess we could put the set of all x's such that x is February, which seems kind of useless to me. In problem 69, we're supposed to decide if this is true or false. And the work isn't difficult, but it is kind of hard to understand what it takes to make an AND statement true. An AND statement is true when both parts, both sides of the AND statement are true. So if 3 is supposed to be an element of this set, then 3 has to make this true, and 3 has to make this true, and then 3 is a member. If 3 fails on either one or both of these, then this statement's true. 3 is not a member. So I claim that 3 is a member because 3, if you put it right here, is a member of the natural numbers, and 3 is odd. So 3 is definitely a member of this set, and so the original statement is false. And that's just a little bit sneaky, that kind of thinking. Problem 71 lists all the odd natural numbers 1, 3, 5, 7, ... and then asks, is 9 one of them? And the answer is true. It really doesn't take much work at all. 77, we've got lion, tiger, monkey in one set, tiger, monkey, lion in the other set. The sets have exactly the same members. They're in a different order, but that doesn't matter. They have exactly the same members, so those sets are equal. But since they have exactly the same members, they also have exactly the same number of elements, in this case 3, so they are equivalent. So the best answer to this question is that they are both. These two sets are both equal and equivalent. Of course, if they're equal, they have to be equivalent. In problem 85, J.K. Rowling has written 7 Harry Potter books. That answers the question, how many books did she write? So that's a cardinal kind of number. A cardinal kind of number answers the question, how many? If a set has 4 elements, you can say it has 4 elements, and that's a cardinal number of the set. Problem 87, Lincoln was the 16th president. That just tells you where he is in the list of presidents. That's a relationship kind of thing, and it's describing the relative position of him to other presidents, and so that's an ordinal number.